please look in the back of the classroom, the one that says graphing quadratic equations number 3. This is a continuation of yesterday's learning. So yesterday we worked with very simple equations. We worked with vertex form, how do we graph them, and then how do we analyze key features. Yesterday the x-intercepts were pretty. They're integer values. Please put a star on the x-intercepts. We're going to jump back to concepts you learned in 8th and 9th grade and apply it now as we identify these key features. Graphing will remain the same. It lies just on the inside. I'm going to go to the left 1 and down 7. Please do the same. Left 1, down 7, and this is my bullseye. It's the vertex. So where the vertex is -1, -7. Going straight through the vertex, I'm going to make this vertical line. The vertical line for quadratic functions is always going to cut through the x-axis. Make sure that you're not just putting down a value of -1, it is x equals -1. Okay? The next thing we're going to do is we're going to graph this. Now normally I would say look in front of the parentheses. So we have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. Your bullseye is always your 0, 0. These guide us in correctly graphing the shape of this parabola. When the number in front is a positive 1, we don't have to multiply by the y values. It'll be the same shape as the parent function. Right 1, up 1. From the bullseye, right 2, up 4. Left 1, up 1. And left 2 up 4. Yesterday, the only difference between yesterday and today is yesterday when you graphed, you could see what the x-intercepts were by simply looking at the graph, and they were nice, pretty values like -2 and +1. They were not going to be in between those dash marks on the x-axis. Today is different. So I'm going to take out a separate piece of paper to show my work. If you write small, you'll have enough room, but you do need to show all of your work. Let me demonstrate right now. Grabbing a separate piece of paper, I'm going to start by identifying the y-intercept. Yesterday we spoke about how when you identify the y-intercept, x is always 0. When you identify the x-intercept, y is always 0. So here we go. I'm writing down the original function, and then I'm going to replace x with 0. And now on the right hand side, I'm going to follow PEMDAS. Easy to work in parentheses. Yes, 0 plus 1. Zero plus 1 is 1. 1 squared is 1. And 1 minus 7 is -6. And that would make sense. -6 is cutting right through here. So when I come up to the y-intercept, I'm going to write it as an ordered pair, 0, -6. You learned that freshman year. We spoke about that in yesterday's lesson. We practiced that. Now here's the difference here. Now we're going to try to find the x-intercepts by making y equal to 0. A couple weeks ago we talked about completing the square method, and we're going to use that right now when it's in vertex form to solve. So when I try to find these x-intercepts and I have to solve for x, bless you, I am doing PEMDAS backwards right now. PEMDAS backwards. So on the side that contains the variable, I'm asking myself, what is outside of the parentheses that I need to add or subtract? So in this case, I'm adding 7 to both sides. Okay, on the side that contains the variable, is there any multiplying or dividing outside of the parentheses? There's not. On the side that contains the variable, is there any exponents that we need to get rid of? And there is. There's a square. Opposite of square is square root. This also tells me we're going to have 2 answers. So on the opposite side, it's plus or minus 7 equals x plus 1. And my very last part here will be to subtract 1 to the opposite side. We're always going to put that last value in front And those are our two x-intercepts. Now, if you're like me, you're like, well, what does that mean? I did all the math. That doesn't make a lot of sense. Well, let's take our calculators right now. I'd like you to practice with me. And let's make sense of this. -1 plus the square root of 7. So 1.6. If I graph this correctly, yep, it looks like it's very close to 1.6. Very close to 1.6. There's 1.6, so it's pretty close. Now I'm going to do it again, and this time I'm going to subtract. And yes, -3.6, -3.6, -1, -2, -3, yes, -3.6. I agree with those answers. We're not looking for decimal answers that are approximations. We're looking for exact answers. So up here, where it says x-intercept, now pay close attention to this. There are two x-intercepts, and you're welcome to write x equals plus or minus the square root of 7. That represents both of them. One time we added, and one time we subtracted to achieve the exact x-intercepts. As we spoke about yesterday with quadratic functions, our domain will remain the same, -infinity to positive for quadratic functions. The range, this goes as low as -7, and there's no limit how high it goes. This particular parabola opens up on the left, and it opens up on the right. So as I go to the far left, it is headed up. As I go to the far right, it is also headed up. I'm going to start by going to the right 2 and up 3. It lies to me and it tells me the truth. Right 2 and up 3. Right 2 and up 3. Now this time we do have an a value, and that's the position of the value directly in front of the parenthesis. We do have an a value that is different than +1. So -1 times all the y values. And this is going to help me in graphing. So 0, 0 is this position. This tells me go to the right one from this bullseye and then go down 1. So I know what the bullseye, or also in the vertex, is the mathematical term. The vertex again is at 2, 3. The line of symmetry is x equals 2. It cuts through the x-axis at a value of 2. Now I'm going to go to the right 2 and down 4. Right 2 and down 4. Left 1, down 1 from the bullseye, and left 2, down 4. I'm going to grab that blank piece of paper and I'm going to start by finding the y-intercept. Now, algebraically, how do I find it? When we find the y-intercept, x is always 0, and when we find the x-intercepts, y is always 0. So for this problem, we'll start with the y-intercept. Y equals -1. I'm going to substitute 0 in for x, and now I'm going to go about solving here. Y equals -1. 0 minus 2 is -2. -2 squared is 4. -1 times 4 is -4. And -4 plus 3 is -1. Let's check. That looks good. So where's the y-intercept? It's at 0, -1. Let's move on to the range. Let's move on to the x-intercepts. So for the x-intercept, I'm going to set 0 in place of y. So 0 equals -1 times x minus 2 quantity squared plus 3. Remember, when you are solving for a variable, we're solving this equation for the variable, we're doing PEMDAS backwards. On the side that contains the variable, let's get rid of adding or subtracting first. So in this case, it would be, what's opposite of adding 3? It would be subtracting 3. Now we're going to move on the side that contains the variable. We need to remove the multiplying or dividing outside of the parentheses. On the side that contains the variable, we need to remove the exponent. Opposite of squaring is the square root, but it also tells us we're going to have two answers. So on the other side, it's plus or minus the square root of 3. And lastly, in order to isolate the x, I'm going to add 2 to the opposite side. So 2 plus or minus the square root of 3 equals x. We got to make sure this looks right. So I'm going to grab the calculator. I'd like you to do the same right now. One time I'm going to add, and the second time I'm going to subtract. And I want to look at my graph and see, is this what I'm getting? So one time I add 3.7. Let's check. 1, 2, 3. 3.7. That looks good. The other time is 0.26. And that looks good. I agree with those answers. So the x-intercepts would be x equals 2 plus or minus the square root of 3. There's no limit how far this goes to the left or to the right. The range, now this is where I saw a lot of mistakes in the last few days. The range always goes with the smaller number first. There's no limit how low it goes, and it rises up as far as 3. What I'm saying is you cannot do it like this. This is not acceptable. It has to be the smaller value first, and then the larger number. For this particular graph, as we go to the far left, it's headed down. As we go to the far right, it's also headed down. Example number 3, I'd like you to start. I'm going to press pause in the video. I would like you to go ahead and graph number 3. Identify the vertex and the line of symmetry. I'll be right back. Our vertex occurs at -3, 5. It lies to us and it tells us the truth. This is my bullseye. Correct term is vertex. My line of symmetry goes straight through, directly through that bullseye, cutting through the x-axis at a value of -3. Okay, let's go ahead and let's graph this. Let's start with the parent functions of quadratic equations. Now, because our a value is different than +1, I must multiply each of these values, in this case, by -4. -16, -4, 0, -4, -16. It's very possible this will be off the graph, but let's take a look. From the bullseye, I want to go right 1 and down 4. Right 1 and down 4. Then I want to go right 2 and down 16. Right 2 and down 16. Left 1, down 4. And from the bullseye, left 2 and down 16. This is a great example. The larger the value, the larger the a value, the skinnier our parabola shape. Okay, let's go ahead. I think we can easily do domain, range, and behavior and come back to do the algebra part for y and x-intercepts. As we've said, for a quadratic function, there's no limits on the domain. The range, always the smaller number first, it goes up as far as 5. Both the left and the right side are headed down. As I go to the far left, it's going down. As I go to the far right, it's also going down. Alright, I'm going to grab a paper now, and we're going to do the y-intercept and the x-intercept. So let's start with the y-intercept. I'm going to set x equal to 0. Y equals -4. X becomes 0. And now think of this just as an expression that you're going to need to evaluate. You're evaluating this expression. 0 plus 3 is 3. 3 squared is 9. -4 times 9 is -36. And -36 plus 5 is -31. I believe that's going down at a very fast rate. It's probably not going to cross the y-axis to a -31. Alright, x-intercepts, x-intercepts. So it's always the opposite variable. So for x-intercept, y is going to be 0. Okay, I'm going to start by subtracting 5 to the opposite side. -5 equals -4. x plus 3 quantity squared. Now this one's going to be more difficult, so you want to keep up with me. This one's going to be more difficult. But I've got rid of the adding or subtracting. I'm doing multiplying or dividing now. Two negatives make a positive. Pay close attention. And now opposite of square or square root. I'm going to have two answers over here, and I'm going to slow this down. So two answers. Square root of 5 over the square root of 4. Two answers plus or minus. And my last step will be to move 3 to the opposite side. So I move 3 over. And we never want to have a final answer with the radical on the bottom. Now we happen to be lucky here. What is the square root of 4? The square root of 4 is 2. So this is what I believe the answer is. Let's make sure that's right. I have a fraction here, so when I plug it in, I do need to use parentheses. Negative 3 plus square root of 5 divided by 2. Make sure it's in parentheses. And negative 3 subtract. You should be doing the same. Square root of 5 divided by 2.
Teachers, at this time we've concluded Bruin's list.
Here,
Please admit those students to class. Teachers, at this time we've concluded Bruin's list. Please admit those students to class.
so I believe it should be about negative 1.8. Just give me 1 second, Jackie. Okay. And negative 4.1. Negative 1.8. So if I did this correctly, it was a little bit negative 1.8 and negative 4.1. That looks to be about right.